Okay, let's move next then to, we're still talking about thresholds, moving from one area to another, okay? And let's take a look next at vision and talk about what are some important issues related to vision. Now, in your book, you'll read about the different parts of the eye, you know, the pupil, which is the black part of the eye, and then the back part of the eye, which is called the retina. Okay. And then on the retina, if we looked at that under a microscope, we'd see then two important types of receptors back here. One that is kind of shaped like a cone, so they're called cones, and cones then pick up color. Most of the cones are in the middle of your retina, so when the light wave comes, you know, through your pupil, goes right back here, and we're able to see color. Although, as we know, about 1 or 2% of the population is colorblind, is not able to pick up either a red-green color or red-green colors or blue-yellow colors. Red-green being more common. So these cones, and here's a way to remember that cones pick up color, because cones and color both begin with the letters CO, right? And then there's another group of receptors here that are more shaped straight, more like this, and these are called rods. So you hear about rods and cones, right? And so rods are not so much in the center, they're more on the periphery part, but they then pick up blacks, whites, and grays, and they are then more adaptable for night vision. And so when you as the lights begin to dim in a situation and the colors begin to fade, then what begins to happen is that our rods begin to take over. Okay, so knowing that then, let's take a look at this thing called light waves. And what we know is that much as with our limits in hearing, we have limits of the spectrum of light waves that we can pick up. And so, you know, when you look in your book, you always see this sort of sliver here, which then has in it this beautiful thing called the rainbow, right? And so what we know is that basically our eyes are capable of picking up the colors of the rainbow. And so the shortest light waves, shortest ones, then are called violet. And so they are around, if we could measure, so rather than dealing with frequency, which gets into the millions, instead what they're measuring is the length of the light wave, right? In other words, as it enters our eye, how wide is it? And so what they've done is taken a look at how do people pick up this information? Well, what is a purple, how is purple perceived? It's about 450 what's called nanometers in length, okay? Well, what's a nanometer? Nanometer is, so think of what a meter is, right? So ask yourself, how much do I know about metric? So how many inches, for example, is a meter? Okay? So what's the answer, right? It's about 39 inches, actually 39.4 inches. So a little more than a yardstick, right? Now think of 1/1000th of that meter. What do you got? You got a millimeter, okay? Then think of a millionth of that, and now you have a nanometer, which is a billionth of a meter. Okay? Now 400 nanometers in length will always show up in our eyes as violet. So, think for yourself for a moment, if I got about 450 or so nanometers in length that I'm looking at, what if I'm looking at something that's slightly shorter than 400 nanometers in length? And then think to yourself, what would that be called? And some of you are getting this. Ultraviolet. Can our eyeballs pick up ultraviolet? No. But find something interesting. Honeybees are able to perceive ultraviolet. For them, that's how much of the nectar that they are able to discover it shows up in plants and flowers and so on. It shows up as this ultraviolet. For us, we just see it as maybe a purplish color or whatever, but we don't see the true color of this nectar. Okay? All right, now let's move up the scale. We're going to go all the way to the other side of the rainbow. So what do we got? We got violet way over here, and now way over on the other side, we're now about 750 nanometers. Okay? And this is the color red. Got it? So as we move, as these light waves are longer in length, then they are moving up in terms of color. So we go violet about 450, sometimes 420 or somewhere around there. Red 750, 780, somewhere around there. Now what's going on? Now what do you think we would call something like 800 nanometers in length? Yeah, infrared. Can we see that with our eye? No, but we can get a goggles or whatever that will then pick up infrared information. Got it? So there it is, and that's our limit. We cannot see light waves out there that are shorter than 450 nanometers nor longer than about 750, 780 nanometers. So there are all these light waves going on out there, but we then, because of our inability of our human eye to go much further than that, are stuck with this narrow range. Got it? So that is another example of perceptual thresholds. That is something beyond which we cannot perceive. Okay? Okay, so that's vision and excuse me, hearing. Sometimes you'll walk into a room and there'll have been perfume or maybe something's burnt or whatever in that room, and if it's been long enough you won't be able to smell it. Okay, but there may be just a hint of it, and you feel like there's something going on here. What is it? Why am I picking up something, and it may be so slight that it's just right at the edge of your olfactory threshold for picking up information about what kind of smell was in this room before you got there. Okay, all right, I think that's ready. That'll get us ready next to talk about examples of people who have developed a sensitivity to sensory stimuli. So what are we talking about here? We're talking about the situation in which people develop their sensory abilities. That is, they see, experience, move around the world in ways that are much better than you or me, or maybe you're one of those people who may be really good at it. Okay? And so one example, if we think of the kinesthetic sense that we talked about already, is that people who are good athletes, someone who's a great soccer player, a basketball player, or golfer or whatever, right? And what have they done? They then have developed their abilities to notice these small differences or small changes. Here's a golfer just ready, to try to line it up and put it in and hit that ball in that hole, right? And so they then have, over the years, developed the sensitivity to, the terrain of the grass and the, how the ball's sitting and how far away it is. And then they've also developed their, their kinesthetic sense of, how much do I move that golf club to, to get it to go where I want it to go, right? Or you think of someone who's this incredible soccer player who's able to be at the right place just as the ball's coming there, and to make their body move in the direction that they want. They're able then to control their kinesthetic sense. So when we think of athletes, we often think of oh, they have these great bodies. Well, that's part of it, but the big part is, what have they done with their brain to train themselves time after time after time? So when they are in that right event, that they can move their body just in the right way to make it happen. I mean, think of all of these amazing athletes at at the Olympics, and whether it's the winter or the Summer Olympics, and all these incredible things that people are able to do with their bodies. So it's a huge investment that people make in their lives, and trying to train their brain to to be sensitive. Another one is, we just think of the sense of smell, olfaction, and the sense of taste. Oh, by the way, if you want to know another term for the sense of taste, you don't have to know it for this class. It's called gustatory sense. Gustatory, gustatory, gustation. And so, what are we talking about here? People who are good cooks, right? People who can smell differences between herbs and spices and know just how much to add and try these recipes out and so on, right? And so these are people who've developed a sensitivity to sensory stimuli, right? Now, you think of audition. You think of people who are great at instruments, or great at singing, who can compose and put together these these amazing tunes. Think of some of the music that you just love, and how they were able to take this music and make it happen because they then. And the question becomes, how much are people born with these abilities? The whole question that is so important in psychology and other areas is nature versus nurture. How much are people sort of born that way, and how much is it that they worked hard to develop whatever this sensitivity is? I've tried very hard to be good at, not that hard, but somewhat hard to be okay at art. And for those of you who remember what my writing looks like on the board, I don't have it there, right? I'm pretty low on the bell-shaped curve, and my guess is that even though I've studied or worked to try to bring myself up to write better and be more artistic, it's just not there. So I think for all of us, it's our challenge to then find out what our talents are that we're already good at. What of our senses that we can develop and take the time to invest in and be good at it. Whatever that is. So those are people who've developed a sensitivity to sensory stimuli. You think of someone who's an artist who paints and can create this picture with depth in it and with color that you just look at it and say, how are they able to do it? And you take a look at a lot of the great works of the world, or people who take a block of marble and then are able to make these incredible changes in it that people would never have been able to guess and determine ahead of time. All right? Okay, we'll take a break for a minute.